Hi, this is Ms. Black, and we are on BIPSI Open Campus 099, and we are in Module 8, and we are actually going to finish the last rule of factoring today. So, we have gone through factoring using the GCF, we have done difference of perfect squares, we have done trinomials, both easy and difficult, and we've done grouping. So what we have last to do today is factoring a sum and a difference of perfect cubes. So again, part of the problem with this rule is understanding the vocabulary words. So let's go to the board. Let's talk about it. Sum means to add. Difference means to subtract. So to do today's rule, you can have two terms that are either connected by addition or connected by subtraction. So it doesn't matter if it's add or subtract as long as it's two terms. Now the key is these are perfect cubes. What does cubing mean? Cubing means to multiply something 3 times. So the first thing we have to know is what numbers are perfect cubes in our arithmetic system. So let's go slow. We're going to make a list of the top 10 perfect cubes. The first perfect cube is 1, because 1 times 1 times 1 is 1. So the next one would be 2 times 2 times 2, which is 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. 6 times 6 times 6, 216. 7 times 7 times 7, 343. 8 times 8 times 8, 512. 9 times 9 times 9, 729. And 10 times 10 times 10, 1,000. Now, it doesn't stop at 1,000, but I'm going to stop. I would expect you all to be able to look at these numbers and know they're all perfect cube numbers. So these are the only numbers we can use in today's rule. Besides numbers being perfect cubes, variables can be perfect cubes. And again, it means multiplying the same letter 3 times. So we're going to make a list. X times X times X is X cubed. That's a perfect cube. X squared times X squared times X squared. Remember, when you multiply, you add the exponents. So that would be X to the 6th. X cubed times X cubed times X cubed is X to the 9th. X to the 4th times X to the 4th times X to the 4th is X to the 12th. Do you notice a pattern with those exponents? They're not all even, they're not all odd, but all of those exponents are multiples of 3. They're your 3 times tables. So to do today's rule, you must have a binomial that's connected by either adding or subtracting. You must have a number that's a perfect cube, and you must have exponents that are multiples of 3. If you have all that going, then you could do today's rule, perfect cubes. So if you look at my expressions, these are both perfect cubes. That's a sum of perfect cubes. That's a difference of perfect cubes. The number 64 is a perfect cube, and the exponent is a multiple of 3. Now, to factor a perfect cube, it's not what you think. You do not put 3 parentheses. You still put 2 parentheses, but they're not going to be the same size. To factor always a perfect cube, it is always going to be a binomial times a trinomial. So you are always going to put a little parentheses and a big parentheses. Always. To factor a perfect cube is a binomial times a trinomial. Now the way I understand this is I have to think of it in words. You're going to make the binomial first and then do the trinomial. So to get the binomial, the first thing we're going to do is get symbols in place. This is the only rule of factoring we put the symbols in first. And there's no other way to explain this. You just have to memorize the pattern. If it starts out as a plus, you're always going to put plus, minus, plus. So I would know when I factor a cube, if it starts out as a plus, it always will go plus, minus, plus, plus, minus, plus, plus, minus, plus. If I'm factoring a perfect cube and it starts out as a minus, it's still going to be a binomial times a trinomial, a little in big parentheses. But if it starts out as a minus, the signs are always going to go minus, plus, plus. Minus, plus, plus. So that's something you have to memorize. Now that you got the signs in place, now we can figure out what's going to go in all these spots. Cubing means 3 times. So to make the binomial, you say to yourself, what did I multiply 3 times to make an x cubed? That would be x. What number did I multiply 3 times to get 64? That would be 4. And you have to watch this number, guys, because not only is that a perfect cube number, it's also a perfect square number. So because we're doing cubes today, what multiplies 3 times for 64? That's 4. Once you get the binomial, you use these terms to make the trinomial. In words, what you're going to do is square the first, square the last, multiply for the middle. So who's first? 4. X. You're going to square it. What's x times x? X squared. Then you're going to square the last. Who's last? 4. What's 4 squared? 16. The middle you get by multiplying these. What's x times 4? 4x. That's the pattern. You have to memorize the pattern. So to factor a cube, you put 2 parentheses, little for the binomial, big for the trinomial. You then get the symbols put in. A minus will always go minus, plus, plus. To get the binomial, you think about the word cube. Cube means 3 times. What did I multiply 3 times to make x cubed? X. What number did I multiply 3 times to make 64? 4. Once you get the binomial in words, you square the first, square the last, multiply the middle. So who's first? X. Square it. X times x is x squared. Square the last. Who's last? 4. 4 times 4 is 16. You multiply these to make the middle. X times 4 is 4x. You don't worry about the symbols. They've already been put in. Now, I know what the question's going to be. Here's a trinomial. Shouldn't we break that down some more? Remember, not every trinomial can factor. This is an easy trinomial because it starts out with an x squared. So watch, even if you try, if you put your 2 parentheses and say, okay, x squared is x times x, then you would say what multiplies to 16 and adds to 4. 16 is 1 times 16. Will that add to 4? No. 16 is 8 times 2. Will 8 and 2 add to 4? No. 16 is 4 times 4. Will 4 and 4 add to 4? No. So when you factor a perfect cube, this trinomial you get is in lowest terms. It cannot break down any further. So factoring a cube will always yield a binomial times a trinomial. And that's as far as you can go. Let's look at one more example in your class notes. Let's look at the last example. It's 8r cubed minus 64. Now, we've discussed this with every rule of factoring. What is always the first rule of factoring? That's right, it's GCF. So you cannot just jump in and do the cube rule until you look and take out what they have in common. GCF means the greatest. What's the greatest amount you can divide both terms by? You're right, it's 8. So we're going to take out our GCF of 8, and you're going to tell me what's left. And that's going to give me r cubed minus 8. So you have to do that first. If you do not take the GCF out first, you're going to be wrong. Now you look. That's a difference. Oh, 8's on the cube list. That's a perfect cube. Oh, the exponent's a multiple of 3. That's a perfect cube. So we're now going to do the rule, difference of perfect cubes. Every perfect cube factors into 2 parentheses. Little, a binomial. Big, a trinomial. When you factor a cube, first thing are symbols. It has a minus, so it goes minus, plus, plus. Cubing means 3 times. What did you multiply 3 times to give you r cubed? R. What number do you multiply 3 times to give you 8? 2. Now you don't even have to think. If you would memorize this list, 8 is in the second spot. That's 2 times 2 times 2. Once you get the binomial, you use these terms to make the trinomial. Square the first. R times R, R squared. Square the last. 2 times 2, 4. Multiply them to make the middle. R times 2, 2R. You know because you did the cube rule, that trinomial will not factor anymore. You cannot multiply to 4 and add to 2. So we know that's in lowest terms. Don't forget the GCF, which was 8. So this whole expression is connected by multiplication, which means you have factored it completely. Thank you.